Alright, so welcome back everyone, welcome back to Children of a Dead Earth. So the current mission is rendezvous and rescue a craft to a disabled ship in Mercury's 4th Lagrange point before it runs out of food. So the time limit is 3 months. So USTA fleet on to Davida was basically diverted from Vesta to Ceres, which is a USF stronghold. They've actually been shipping off many of our warships from Ceres to Vesta when they made the invasion burn to Ceres. So they pretended to head to Vesta and instead went for Ceres. We only had a month to react, far too little time to execute a turnaround of those ships, and far too little time to muster any forces from any of our other major rocks in the belt from Vesta or anywhere else. So United Sultry Allies USTA fleet wiped our remaining defence fleet around Ceres except our flagship. When the battle went badly, the rest of the fleet was sacrificed to cover the escape of the flagship, which fled Ceres into a solar freefall. It afterwards used the last of its Delta V to capture into a tadpole orbit around Mercury, Sun Lagrange point number 4. So the flagship holds one of our most esteemed military leaders, Admiral Yanti Seteja, commander of the Ceres Defence Fleet, and the crew has somewhat over 3 months of food left. As they were not planning for such a situation, we have a methane tank in orbit around Mercury, rendezvous with the disabled ship, and rescue the crew before they run out of food. We'll send more ships later to recover the flagship when they can finally arrive at Mercury. But for your mission, you just need to rendezvous with the flagship before one of our top brass starves to death. So you see at the bottom, I have attempted this already. It took 2 months, 15 days. I spent 17.4 kilometers in second Delta V. The record is 1 month, 28 days. 11.8 kilometers a second Delta V spent. So let's see if I can better my own. I don't think I'm going to be able to equal the record though. Alright, so in case you haven't discovered it already, you can toggle on and off the visibility of Lagrange points. I actually set them on by default in the settings. So I actually just turned them off now. So I'll turn them back on. So all 5 of Mercury's Sun Lagrange points have shown up. However, the only one you should worry about is the L point, which is what the target ship is orbiting right now. So I'll click on that. This is the point that your target is orbiting in a tadpole orbit. Now, exactly as I said at the beginning of this entire series, this game uses n-body physics, which is the same equations, the same effectively orbital mechanics, orbital model that NASA uses to planet's slingshot maneuvers, its gravity assist maneuvers for its probes. This is the point that your target is orbiting in a tadpole orbit. When you get closer, you may want to use it as your frame of reference. Right, so go ahead and select our tanker. So see how it's a methane tanker once again. Take a close look at it. It's no different than the previous one that was in charge of. So it can be used to refuel, but it can also refuel itself from other sources as well. We've got 21.8 kilometers a second. Delta V sounds like a lot when you're chasing Lagrange points. It's not quite as straightforward as you might think. It's not the same as a standard maneuver, orbital mechanical maneuver. The plane's slightly more difficult. Alright, so we'll go ahead and
incoming transmission.
Begin planning the maneuver. Okay, so you're going to need to escape Mercury's gravity and fall into an orbit around the Sun, heliocentric orbit in other words, to get to the Mercury L point, Sol L point. Because L is in front of Mercury along Mercury's orbit, you'll want a tighter orbit to catch it up, so you need to burn retro that way. On the daylight side of Mercury, basically, that's what they're trying to tell you. You should select a point on your trajectory nearest to Sol. This is because your ship will be going in the opposite direction of Mercury. Not technically speaking, will be slowing down, relatively speaking, as far as Mercury is concerned. So because the radium will be travelling along is less. we actually effectively accelerate and pass Mercury. Yes, that's the theory anyway. So on the other side of Mercury, you'd have to essentially make a retrograde burn to escape Mercury's orbit. So if on the dark side, you have to be thrust in that direction, which is quite challenging because you're more likely to hit the surface of the planet over the other body that you're actually orbiting. So I'm going to center the camera. So we want the daylight side. I'm going to try and do this in a single burn. If you have the correct point, escaping via tangential burn, there's a red handle, is vastly more delta V efficient than via a radial burn. You should need much less than 1 kilometre a second, so you shouldn't need a kilometre a second to just get Mercury's orbit this way. But I'm going to try and do it a different way. Just touch that. I'm going to right click on it so it cancels it. Your trajectory will achieve a skip from Mercury's orbit if the line curves away from Mercury rather than remaining in an ellipse. Once you have that, so it means over here. So it means over here rather than like that. We don't want this being stretched like this. We want it over here. So once you have that, you want to change your frame of reference next. Yeah. Okay, assuming your trajectory escapes Mercurial orbit, having Mercury as a frame of reference makes no sense. Let's just do that. Now zoom out as far as you can. If you have successfully made an escape trajectory from Mercury, your orbit should now appear to be a circle or eclipse around Sol, indicating that your ship will be orbiting Sol rather than Mercury. You should be able to figure the rest of the intercept out on your own. So, yeah, so good luck. I'm probably going to need it. So I've got 21.8 kilometers a second. I haven't done the escape burn. So you can see where it's projected it. Over here. I've no idea why it's done that. It's going to take us... how long? Is it about 6 days? About 6 days to get there. I'm going to try this. We'll see. It's moved further forward. That's because orbiting Mercury is, for some reason, it takes like 6 days to go around to from where we were to where we want to be before we try and escape. It's a bit strange. .6, obviously that's far too much. 4.2. So we can cost at least 14 kilometers a second. No, not of delta V. So it said 14.4 kilometers. Yeah, it says here 30. And here it actually says 6 days, 4.2, and it's a month. It says 26.1 kilometers, so it's actually 30 kilometers. So that's no good. I'm going to cancel that. Zoom back into Mercury. So we'll set Mercury as our frame of reference. Obviously we haven't escaped it yet. So if we burn from there, it takes 5 days 22 hours to get there. So I shall try this. It's not exactly retrograde though. I'm losing more than actually it says you should, but okay. So another join just here. 1 month, 18 days. Costs 17.3 kilometers a second. That's probably going to double. Yeah, thought so. 40. That's a lot more than it said it was. Bit of a pain in the backside, isn't it? Oh. Okay, so what happens if we do that again? Let's see if you push more and more. It's just going to cost you more and more delta V. Yeah, 17.5. Going to take 2 months. No way. So I've got extend trajectory. No, join failure. Yeah, it's a bit misleading when it tells you it's going to cost you a certain amount of delta V. And then it more than doubles it. Okay, let's head back in. So really we need to eject us close. Yeah, that looks a lot better. Probably won't be, but I mean, we could actually slow down. We don't need to speed up, we could slow down. What's it's going to take a lot longer. Alright, we're just going to use... It says you shouldn't use more than 1 kilometer a second anyway. It says much less. Alright, so we're going to eject ourselves with 600 meters a second. It's going to take 6 days to get into position, which is a bit strange. No, 6 days. There we go. 2 hours. Right, so that should be the manoeuvre done. Yeah, so our ship is travelling like that, relatively speaking, to Mercury. Get that round. So that's Lagrange point. So we need to try to join there. Okay. So we're now ejected. So now we need... Of course, every time we think we'll get closer to the Lagrange point, it will move further away from us if we're not going fast enough. It'll take 2 months to get there. Far too long. It'll take 1 month to get there. Obviously, we're not going slow enough. So we need to brake even more. That's 3.6 kilometers a second. Yeah, it said we shouldn't use more than a kilometer. Okay, hang on a second. Let's see, move. Fair reference to Sol. Well, that is definitely... It'll take 18 days. But we're not faster because a Lagrange point is actually moving away from us. So we're not much closer. Let's try radial. Radial in first. Probably won't work. Okay, radial out. No. No, 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 no. It's a bit sticky. Yeah, nowhere. No, obviously not. Nope. Just play around with it, I suppose. Probably going to take too much delta V. 1 month, 14 days. Going to take 16. No. That's probably not going to work. No. Yeah. Exactly as I said. 38 kilometers a second it wants. So what's the 16 kilometers about? Oh, it's telling me. Very strange. Obviously, intercepting will cost certain amount of delta V. Then obviously matching velocities with the target cost you a big chunk more. As I said with previous missions where we tried to rendezvous, you want to be as close as possible. You want to just brush past the target, not head it, sort of almost head on or perpendicular at right angle. It costs you a lot more delta V to match. But it's in the same phase. What is it? Let me have a look. Yeah, it should be, because obviously it's relative to Mercury. It's Mercury's L point. Which one I can actually try and do. I can't figure anything else out. Got to go faster. Got to go fast. We've got to go slower. And it says you should need less than 1 kilometer a second to escape. Quite obviously, you need more. I've got to be able to move faster. And you can see, I mean, you move further and further ahead. Lagrange point just moves ahead of us, even along the track that we've got. Yeah, it should be the same velocity as Mercury, surely. So I managed this in about 2 months. I think it was 2 months, 18 days was the previous record for me. And I kind of heckers like recreate even that. Oh dear me. That's going to take 21 days. I think I was on 46 minutes. Yeah, we're not going to be able to do that. Yeah, we've got the same intercept point again, but 3.1 kilometers a second. Yeah, I don't think it's going to work. Oh. Oh. 13, damn it. Just over the record then. It'll take a month to get there though. They're almost out of time. Obviously it doesn't tell you the total. Only tells you for that actual manoeuvre.
Incoming transmission.
Yeah. That's actually worse than I did before. Less delta V, but it took more time. It took, what was that? 7 days. 7 days longer. Oh well. It's rather a tricky the entire game actually, entire mission, all the missions are a little bit sort of hit and miss. What works for one, you replay that same mission again, it won't work again. It's very random-ish. So I've got 2 months, 22 days. My best was 2 months and 15 days. The record is 1 month, 28 days. How the devil do you do that? I think it's quite misleading as well, the instructions. It says less than kilometre a second. But if you use more, you can actually get there a lot faster. And actually ultimately use less delta V. So it's not really giving you the best advice. So I use 15.9 kilometers a second, which is considerably less than 17.4 kilometers a second, which is what I did for the 2 months and 15 days. But nowhere near as low as 11.8 kilometers a second. But never mind. Okay. On to the next mission then.